Hello everyone, let us see the next chapter. The name of the chapter is Fourier series. Before that, before starting the definition of the Fourier series, we have to go through these concepts. The first one is periodic function. A function f of x, generally we denote function as f of x, g of x, like this. A function f of x is said to be periodic function of period capital T if f of x is equal to f of x plus t is equal to f of x plus 2t is equal to f of x plus 3t and so on is equal to f of x plus this 1 2 3 up to n natural number nt. T is a period of this particular function. If such thing happens with this number t, then t is called the period of this f of x, and f of x function is called periodic function. Okay, for example, what is the meaning of this is this is the x and y axis. This is a 0 degree, right? This is a 90 degree, pi by 2. This is pi. Okay, again this is a 2 pi. Okay, if you start with the sine 0, sine 0 is 0, sine 90 is 1, sine pi is again 0, sine this is 270 is again opposite of 1 is minus 1, and sine of 2 pi 360 degrees again on the same number, that is 0. That means if you go on adding pi by 2 number, pi by 2 degree to this pi 2 pi, you will get the circle end with the same number. Okay, that's why the sine function is a periodic function whose value gets repeated after 2 pi, and 2 pi is a period of sine. That's why sine function is a sine x is a periodic function of period 2 pi. Similarly, cos also. Okay, cos 0 is 1, cos 90 is 0, cos 180 is minus 1, cos 270 is 0, and again cos 2 pi, that is 360 degrees, again 1. If you go on calculating the same cosine angle of any angle by adding pi by 2, it will get repeated after 360 degree, the same numbers. That's why cos x is also a periodic function of period 360 degree, that is 2 pi. Okay, next even function. If f of x is equal to f of minus x, means any function, if we replace that function x by minus x, and if that function remains the same, then the such function is called even function. For example, it is x square, okay, x cube. Okay, f of x is equal to x square, f of x is equal to cos x. These are the even function. Why? Because if f of x is equal to suppose x square is a function, if you replace x by minus x, okay, what it becomes? Minus is replace everywhere x by minus x, rest of the terms as it is. So minus x square is as it is, and we know minus square is plus x square, and this is the same as the original function f of x. That's why f of minus x is equal to f of x. In such case, this type of function is called even function. Similarly, cos also, if you replace x by minus x, we know cos of minus theta is plus cos theta. The function remains same. That's why cos is also even function. In the opposite of that, odd function, what is the meaning of odd function? If f of minus x is equal to minus comes outside of the function, this means minus of f x, then such function is called the odd function. For example, x cube. Suppose x cube, f of x is a x cube, f of minus x becomes minus x cube, and we know minus 1 minus 1 minus 1 3 times becomes minus, and x cube as it is, and this particular function is our original function minus this original function f of x, right? That's why f of minus x in this case is equal to minus comes outside of the function minus f x. Such functions are called odd functions. Similarly, sine also. We know sine of minus, if you replace x by minus x, it becomes sine of minus theta. And sine of minus theta is a minus sine theta. Minus come outside of the function. That's why sine is again a odd function. These are some examples and terminologies before we start our main point of Fourier series. Okay, these are some notes. Already we have seen such notes. Integration of minus a to a is in a number f of x dx is equal to 2 times minus a to a, the middle number. This is a number line. Okay, this is 0, middle number is 0, this is 1, this is 2, dot dot, and on the opposite side the negative integer starts minus 1, minus 2. Okay, the distance or the middle point of minus 1 to 1 is 0. The middle point of minus 2 to 2 is again a 0. Any number minus a to a, the middle number is 0, middle point. That's why minus a to a fx dx becomes 2 times 0 to a fx dx if a particular function fx is even function. Okay, and if a function is odd, then this integration is 0. This is the meaning of this. Okay, this is a result of integrations or formulae. Again, even into even function is even function, even into odd is odd function, and odd into odd is even function. It's like negative into negative is a positive, positive into positive is again a positive, and if any one of the sign becomes odd, then that means positive into negative or negative into positive becomes negative. Okay, now u into v rule, we know this is a product rule. U into integration of v minus u dash, u double dash, u triple dash, take on the derivatives of u, and suffix means integrations. v1 means first integration, v2 means first, second integration means integration of first, v3 means integration of second, v4 means integration of third, and so on. This is the u into v rule, alternating plus minus sign. Now these are some values we have to mug up, because these are the we are using consistently in every almost every examples. Okay, sine 0 is equal to 0, sine pi, sine 2 pi, sine 3 pi, sine n pi is again 0, sine 2 n pi, these are all zeros. Okay, cos 0 is 1, cos pi is opposite minus 1. You can calculate on calculator also. Cos, so pi means 180 degree, cos 180 in the calculator it becomes minus 1. Cos 2 pi means cos 360 is 1, that is cos of n pi is minus 1 raised to 1, and cos of 2 n pi is 1. Okay, these are the some values. You have to mug up all these things. Let us start with the definition of Fourier series. These are also formulas. 2 sin a cos b is sin a plus b plus sin a minus b. 2 cos a cos b is sin cos a plus b plus cos a minus b. 2 sin a sin b is just reverse this, cos a minus b minus cos a plus b. Okay, now let us see the definition of Fourier series. Let f of x be any periodic function, okay, of period t is equal to 2 pi. Then Fourier series of fx is given by this formula. We have to mug up this formula. Whole chapter is depend on this just three formulas. Okay, fx is equal to a naught by 2 plus summation n running from 1 to infinity an suffix an cos nx plus summation same terms, instead of an this is bn, instead of cos this is sine, summation n over n bn sin nx. And range of this particular Fourier series, range means interval on the number line, is alpha plus 2 pi. Okay, where a naught, an, bn are the calculations in the examples, where a naught formula is 1 upon pi. This is the interval as it is. We have to take the interval alpha to alpha plus 2 pi fx function fx dx. an is 1 upon pi, range is same, fx into just multiply by cos nx dx, and bn is just replaced by cos by sine, rest everything is same. Okay, these are the formulas of Fourier series. These are the only formulas. Okay, now first type There are types depend on the intervals. First we are going to see the interval of 0 to 2 pi. Okay, Fourier series in the range 0 to 2 pi. Alpha comma alpha plus 2 pi range becomes 0 to 2 pi. That means alpha is 0 here. Okay, now for example, let us start with the example. Find the Fourier series for fx. Function is given e raised to minus x in the interval 0 to 2 pi. Okay, now Fourier series is given by in the interval 0 to 2 pi as fx is equal to a0 by 2. Our first step of every example is this same. Okay, Fourier series is given by this formula, summation a n cos nx plus summation b n sin x over n 1 to infinity. Call that equation number 1 always. Now we have to calculate a0, an and bn by using formulas. These are the only lengthy examples. Okay, and integrations are there. A0 is 1 upon pi, integration now becomes alpha to alpha plus 2 pi is the range, and in this particular range is 0 to 2 pi. Therefore alpha to alpha plus 2 pi replaced by 0 to 2 pi. Alpha is 0 here only. Okay, fx dx. Now put the value of function fx e raised to minus x dx, and we know e raised to minus x integration is e raised to minus x upon derivative of minus x is minus 1 from 0 to 2 pi. Put the value of take this minus 1 outside, minus 1 upon pi. Put the value of x first, upper limit e raised to minus 2 pi minus e raised to 0 lower limit. We know anything raised to 0 is 1, and this is minus. Take this minus inside and reverse this term. Answer of a naught is 1 upon pi 1 minus e raised to minus 2 pi. Okay, next an 1 upon pi integration 0 to 2 pi fx cos nx dx. This is the formula for an. Now put the value of fx here, e raised to minus x. Okay, now we know formula of e raised to ax cos bx. You can write here, no problem. Integration of e raised to x cos bx dx and integration of e raised to x sin bx dx. How to mug up this formula? Just remember this trick. E raised to x upon a square plus b square. Here also e raised to ax upon a square plus b square. What is a, what is b? This is a, coefficient of the variable x. What is b? Coefficient of angle x. Okay, now bracket. This is a as it is cos bx. Here also a as it is sin bx. Okay, for cos it is plus, cos for sin it is minus. Okay, now reverse the term. Instead of a it is b, instead of a it is b, instead of cos this is sin, angle is same. Instead of sin this is cos, angle is same. This is the formulas. Okay, now in this particular formula we are going to use this e raised to x cos bx. Here a is minus 1. Okay, coefficient of x, and b is coefficient of x n. B is n. Put the value here as it is, e raised to x upon a square plus b square is e raised to x upon minus 1 square. You can write down only 1. Minus 1 square is a plus 1. 1 minus 1 square plus b square is n square. Bracket a cos bx, that is minus 1 cos nx plus b is n sin nx. Bracket complete 0 to 2 pi. Put the value of 2 pi, and we know sin 2 pi is again a 0 and cos sin 0 is again a 0, and cos 2 n pi, instead of x replace 2 pi here. Just take this constant, we are putting the limits in x, that's why 1 square plus n square take outside, and put now 0 2 pi first, e raised to minus 2 pi, bracket cos minus cos 2 n pi plus n sin 2 n pi. This is upper limit. Now minus lower limit 0 we have to put in x, e raised to 0, and bracket cos 0 is 1, and this is minus as it is, and sin 0 is 0, 0 into n is 0. Bracket complete, lower limit complete, square bracket complete of this. Okay, now we note cos of 2 n pi is 1, sin of 2 n pi is 0. That's why answer is this is as it is, e raised to minus 2 pi. this is minus as it is, this value is 1, this is 0, and this is again e raised to 0 is 1, minus minus becomes plus 1. Okay, now e raised to 2 pi, this is minus, and 1 minus e raised to minus 2 pi divided by this pi into 1 plus n square. This is the value of an. Now similarly we have to calculate, once you find out an, bn is very easy, because what is the difference between an and bn? Here there is a difference between an and bn, just replacing here cos by sine, rest of the terms are as it is. Okay, now let us start with bn. bn is 1 upon pi, formula first, 0 to 2 pi fx sin nx. Now put the value of fx, e raised to minus x sin nx. Now you are going to use this formula. Okay, sine. A is again same, minus 1, b is n. E raised to minus x upon minus 1 square plus n square, formula 1 upon pi as it is, a sin bx, that is minus 1 into sin nx, minus, for sine, middle sign is minus, b, that is n, cos nx, instead of sine, that is cos nx, bracket complete, square bracket complete, limits are 0 to 2 pi. Now we have to solve, take minus common, take outside, minus 1 upon pi into this 1 square plus n square outside. Now put the value upper limit, e raised to, here in this next step, e raised to minus 2 pi sin 2n pi plus n cos 2n pi, minus lower limit 0, e raised to 0, sin 0 plus n into cos 0. We know sin 0 is 0, cos 0 is 1, sin 2n pi is 0, cos 2n pi is 1. Therefore answer is minus 1 upon this as it is, e raised to minus 2 pi, 0 plus n minus this 1, 0 plus this again n. Therefore simplify n into this as it is, minus this n. Take n outside, upon this e raised to minus 2 pi minus 1. Reverse this sign, take minus inside, we get n upon this as it is into 1 minus e raised to minus 2 pi. This is bn. Now what we have to do? We have calculated a naught, an and bn. Now put these values in our answer for equation number 1. This is the our main question, find the Fourier series, and Fourier series is given by this formula. In that formula we have calculated a naught, an and bn. Once you calculated a naught, an and bn, we have to just put those values in this equation, that's it. Therefore final answer, Fourier series from equation number 1 is given by fx is equal to a naught by 2, this is a naught, a naught by 2 means just divide by this 2, we get this 2 divided by, this is a naught, plus summation an, this is an, write down this an as it is, cos nx, plus summation bn, this is bn, sin nx, that's it. Now summation is over n, from 1 to infinity same summation, therefore we have to take common from both the term, that is 1 minus e raised to minus 2 pi. Common means the terms which are not containing n, because summation is over n, the bracket doesn't contain n, okay, that's why, and divided by pi, take outside, and in the summation it becomes cos nx upon this 1 plus n square plus sin n into sin nx upon this 1 plus n square. Base is same, just add a numerator. This is our most simplified final answer. On LHS, fx becomes e raised to minus x. This is our original function. Okay, this is called the Fourier series of the function f of x. Okay, now let us see the next example so that you will understand more. Find Fourier series for the function f of x is equal to x in the interval 0 to 2 pi. Again same step, Fourier series is given by fx is equal to this formula, a naught by 2 plus summation an cos nx plus summation bn sin nx over summation n is equal to 1 to infinity Here also same. Call that equation number 1. Now we have to find out a naught first. This is 1 upon pi integration 0 to 2 pi. Range is same, that's why formulas are same. 0 to 2 pi fx dx. 1 upon pi, put the value of fx is x dx. Integration of x is x square by 2. Limits are 0 to 2 pi. Take this 2 outside, 1 upon 2 pi. Put the limit, upper limit 2 pi here. We get 2 pi, its square, minus lower limit 0, that is 0. 1 2 pi gets cancelled, answer is only 1 2 pi remain. This is simply a naught. A naught is very simple. Now calculate an. An is formula 1 upon 2 pi. 1 upon pi integration 0 to 2 pi fx cos n x. Put the value of fx is x cos n x dx. Now here we have to use u into v rule. What is u, what is v depends on the Liet rule. This is logarithmic, this is inverse, this is arithmetic, this is trigonometry, this is exponential. Cos is a trigonometry and x square, x cube is a arithmetic. That's why this is u, this is v. Now start with the formula. U into integration of v. Cos nx integration is sin nx upon derivative of angle should be divided with respect to x, that is n. Now second term, put the brackets everywhere. Now second term is minus into u into v rule. It's x derivative. This term's derivative here. X derivative is 1 and this term's derivative is here. In that n is a constant as it is. Sin nx derivative integration is minus cos nx upon n, and already n is there, that's why it becomes n square. Now next term of u into v rule is plus 1 derivative here, that is 0 because 1 is a constant. That's why the process stops here of u into v rule and limits are 0 to 2 pi. Everywhere we are going to use same rule. Therefore now remove the bracket first before putting the limits. X into sin nx upon n plus this minus becomes plus cos nx upon n square 0 to 2 pi. Now put the value of 2 pi in x everywhere. Upper limit first. 2 pi into sin 2 pi n divided by n plus cos 2n pi divided by n square. This is upper limit. Minus lower limit, put 0 in x. X into 0 into anything, it becomes 0. Cos 0 is 1 upon n square. This is total lower limit. Now we know sin 2n pi is 0. Cos 2n pi is 1. That's why answer is 1 upon n square minus 1 upon n square. And the opposite cancels throughout, we get 0. An is 0. Now next bn. What is the difference between an and bn? Just replace cos by just sin here. Rest of everything is same. Now bn formula is 1 upon pi integration 0 to 2 pi fx sin nx dx. Integration 0 to 2 pi fx is our function x into sin nx. U into v rule again. This is u, this is trigonometry v. 1 upon pi integration u into integration of v. Sin nx in sin integration is minus cos nx divided by derivative of nx is n. Minus x derivative is 1 minus as it is cos derivative is plus sin nx upon n, and already n is there, becomes n square. This is minus sign of this minus sign as it is constant. Okay, and integration of cos is plus sign and integration of sin is minus cos. Remember this difference. There is a derivative and integrations formulas are exactly opposite to each other because derivative and integrations are the reverse process of each other. Okay, now next term will be plus 1 derivative 0. That's why u into v rule stops here. Limits from 0 to 2 pi as it is. Now put the before putting the limits, just remove this bracket. This is minus x cos nx upon n minus becomes plus sin nx upon n square. Put the limits first. Now 2 pi here. You can cancel this sign in upper and lower limit itself. Yeah, no need to write down this step. Okay, this is upper limit. Everywhere we are putting 2 pi and minus lower limit becomes 0 because lower limit, if you put 0 here, it becomes 0 into anything is 0 and sin 0 is 0. That's why lower limit becomes 0. Simplify, we know cos 2 n pi is 1. That's why answer is minus 2 pi upon n. Sin 2 pi is 0. You can write everywhere until you mug up all these things. Okay. Now minus pi gets cancelled. Answer is minus 2 upon n. Now put this value in equation number 1 of Fourier series. Fx is a naught by 2. A naught is minus a naught is 2 pi by 2. A naught is 2 pi by 2. 2 pi by 2. 2 gets cancelled in next step. And plus an cos nx. An is 0. That's why no need to write 0 term. Plus summation bn sin nx. Bn is this. Therefore summation n from 1 to infinity bn. We can put bracket into sin nx. This is the answer. Now take the constant outside. Constant means regarding this summation over n, it's the apart from n everything is constant. Take outside of this summation. 2 gets cancelled. Answer is pi. This minus 2 take outside because it is constant. Summation over n sin nx upon n. This is the final answer for Fourier series of function fx is equal to x. Now let us see next example. Find Fourier series for the function fx is equal to 1 by 4 into bracket pi minus x bracket square in the function in the interval 0 to 2 pi. Interval is same. Now Fourier series formula is same as it is write down and call that equation number 1. Now I have to find out a naught. A naught is this formula 1 upon pi integration 0 to 2 pi fx dx. Put the value of fx 1 by 4 pi minus x bracket square dx. Take 1 by 4 outside because it is constant. Pi minus x bracket square integration is it is arithmetic. Therefore we have to apply integration of x raised to n here. X raised to n plus 1 upon n plus 1. Therefore integration here is pi minus x bracket square integration is pi minus x bracket cube upon 3, and the derivative of bracket should be divided. That is the rule of integration, that is derivative is minus 1 with respect to x. Bracket complete. Limits are 0 to 2 pi. Now before putting the limits we have to take constant outside. This 4 into minus 3 minus 12 outside. Okay. Now this total take outside. Now in the numerator put x as equal to 2 pi. Pi minus 2 pi its cube. Upper limit becomes this. Minus lower limit put x is equal to 0. It becomes pi minus 0 cube. Bracket complete. Okay. Now pi minus 2 pi is minus pi. Minus pi cube becomes again minus pi cube. And this is minus as it is and pi cube. Minus pi cube, this is minus 1 upon 12 pi as it is. Minus pi cube is minus this becomes take cancel with this. It becomes addition plus 2 pi cube divided by 12 pi. Now 2 6 are 12 and 1 pi gets cancelled. Answer for a naught is pi square by 6. Okay. Let us start with an. An is equal to 1 upon 2 pi integration 0 to 2 pi fx cos nx dx. This is a formula for an. Put the value of fx 1 upon 4 bracket pi minus x bracket square cos nx dx. Now take 1 by 4 outside. Integration becomes pi minus x bracket square into cos nx. Now this is arithmetic because pi is a constant. It contains only x. Therefore it is arithmetic. That's why it is u. This is trigonometry. That is v. Start with the integration of u into v rule. U into integration of cos is sin nx upon n plus sin nx upon n. Now next term is minus this derivative here. This is the rule of minus. This minus sign is comes in the rule of u into v rule, and we have to put now take the derivative of this term. What is the derivative? We have to apply x raised to n derivative. What is the derivative of x raised to n? Dash n into x raised to n minus 1. That's why answer is 2 into pi minus x raised to 1 and into, by the chain rule formula, we have to multiply the derivative of this bracket, that is minus 1. This is the derivative of this term. Okay, this is the, now this integration here, sine integration is minus cos n x upon n. Already n is there, that's why it becomes n square. Now next term minus plus minus, this is plus again. Derivative of this, in this derivative minus 2 is a constant, take it as it is, and derivative of this bracket is again minus 1. Okay, this is the derivative of this term. Now this integration here, in this n square is a constant, minus is again as it is, cos integration is sin nx upon n. Already n square is there, therefore it becomes n cube in the denominator. Bracket complete, limits from 0 to 2 pi. Okay, now before putting the limits, we have to cancel this bracket. Pi minus x square sin nx upon n as it is. Now minus 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 3 times minus, therefore single time minus 2 into pi minus x into cos nx upon n square. This again minus 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 3 times minus becomes minus 2 into sin nx upon n cube. Bracket complete, 0 to 2 pi. Now again sine terms gets cancelled because we know sine of 2 pi n for upper limit is again 0, and for lower limit sine 0 is again 0. Therefore for both the limits sine terms gets cancelled. We have to concentrate only middle term minus this. Now put the value of 2 pi in x, we get this as it is, minus 2 as it is, pi minus 2 pi becomes minus pi, cos of 2n pi divided by n square, this becomes upper limit. Now for lower limit put minus, put the brackets. Compulsory we have to put the brackets for the lower limit, don't forget that. Okay, now put the lower limit 0 in x, it becomes 2, that is minus 2, it is minus sign there, minus 2 pi minus 0 is pi, cos 0 is 1 upon n square. Okay, bracket complete, square bracket complete. Now we have to simplify this. This minus minus becomes plus 2 pi. Now value of cos 2n pi is 1 divided by n square as it is. Now minus minus becomes plus 2 pi upon n square. 2 pi upon n square plus 2 pi upon n square becomes 4 pi upon n square, and this 4 pi as it is here. 4 pi gets cancelled. Answer for an is 1 upon n square. Okay, now start with the bn. What is the difference between bn and an? In an here cos is there, in bn is sine is there. Same formula. Okay, these are the steps. I'm not going to explain this because this is very easy. Once you find out for cos, it is just like that, same for sine. Okay, steps are also same. These brackets are very important. Okay, now if you see, these all terms gets cancelled, answer becomes 0 for bn. Therefore put the value of a naught, an and bn in the original Fourier series equation 1. We get fx is equal to, this is a naught by 2, that is pi square by 12, plus summation an 1 upon n square cos nx, plus bn is 0. This you need no need to write 0 here also. Therefore fx value is 1 upon, function value is 1 upon 4, pi minus bracket square is pi square by 12, plus summation over n 1 to infinity 1 upon n square cos nx. This is the final answer for Fourier series of fx.